All right, before we start going through the examples in this section, I want to try to unpack a little bit on why this technique works. We're going to be factoring uh, trinomials where that first term is not a 1. And one way to sort of look at that is to sort of go backwards. Let's go ahead and look at what we've seen before. Back in the last unit, we would have something like this, 3x plus 2 times x plus 5, and we would use that FOIL technique. We would say 3x times x is 3x squared. 3x times 5 is plus 15x. 2 times x is plus 2x. And then 2 times 5 is 10. And so one thing to note here is that, well, and then we would finish that off, right? We would combine those like terms, and we would get 3x squared plus 17x plus 10, and you'd be done. Now what we're going to be given is I'm going to give you this, the 3x squared plus 17x plus 10, and ask you to get the factored form. And so our normal technique of finding factors of 10 to sum to 17 is not going to work because a is not 1, a is a 3. So let's unpack on this technique. I'm going to show you on sort of why it works the way it does. Let's go back to this, the term here, right before we got the answer in combined like terms. Let's look at this here. So 3x squared. And let's note the factors just numerically of each of these terms. So this first term, we get the factor of 3 times 1, a little box around it. This one here, 3 times 5. This one here, we did 2 times 1. And this one here, we did 2 times 5. So one thing to note, look at our last two factors. So the last two factors are 3 times 1, 2 times 5. So 3 times 1 and 2 times 5. And how about the middle two? So my middle two factors were 3 times 5 and 2 times 1. Now notice it doesn't matter what order we multiply in. 3 times 1 times 2 times 5 is what? Well, 3 times 1 is 3, times 2 is 6, times 5, we get 30. 3 times 5 is 15, times 2 times 1, we get 30. Those are the same. We get the same when we multiply that out. And so we're going to leverage that to find how we can kind of split that. So what we're looking for here is that we're wanting to find a way to split this 3 times 10. To give me that 30. So find a way to split 3 times 10, that product, which is 30, so that when we add those two factors, we get that middle term of 17. So how can we do that? So in this example, for instance, when we find factors of 30, the sum to 17, we know that's going to be 15 and 2. The other factors just don't work, right? I tried 5 and 6. Those don't sum to 17. 3 and 10 don't sum to 17. 30 and 1 don't sum to 17. Only 15 and 2. So I'm going to use that fact to leverage how I'm going to split that up. And so if I were given this right here to begin with, when I'm given this 3x squared plus 17x plus 10 to begin with, I know I can split that up as the 3x squared plus 15x plus 2x plus 10. I'm just using the fact that I'm trying to find factors of this 30, the 3 times the 10, that sum to that middle term. Now what can I do is I can use my factoring by grouping. I can group up each of these and then pull out what's my common factor in this first group? 3x. And what am I left with? I'm left with x plus 5 plus 2 times x plus 5. Now this will always happen if it's factorable. And so I can pull out my x plus 5, and I'm left with 3x plus 2. Sorry for the change of color there. which again is the same thing we got when we started. So in this lesson, you're going to be given this, and we're going to use this method called the AC method to come up with this. Now, there are a myriad of methods on how to factor. I'm just going to show you one, maybe two, on how to factor these. And to some extent, you don't really have to know why this works sometimes, but I felt like it obligated to show you sort of why this AC method works, sort of deconstructing the terms there. Okay, so here's where the examples start, and I kind of unpack how to do that here. Again, it's easier to show you than it is to say to write it all out. So let's look at this first one. So 6x squared plus 7x plus 2. That AC method says I take a times c, multiply a times c, so a times c is 12. Or factors of a times c that add to that middle term. So factors of 12 to add to 7, well, that's going to be 4 and 3. You can write them all down if you want and find the ones, but I think when these numbers are fairly small, you can kind of go straight to it. And so then I'm going to rewrite this, 6x squared plus 4x plus 3x plus 2. Doesn't matter what order you write these in, it's going to be grouped slightly differently. Okay, and then I'm going to group this up. Pull out your common factor in this first group of 2x. And what am I left with? 3x plus 2. And then it's just a 1 there, right? You can put a 1 if that helps. 3x plus 2. Like before, what's common in both of these? This 3x plus 2. So let's factor that out. And I'm left with 2x plus 1. And I'm going to leave it up to you to FOIL that back out. Well, let me do this first one. The 3x times 2x is 6x squared. 3x times 1 is plus 3x. 2 times 2x is plus 4x. And 2 times 1 is 2. Notice, we have this right here. This is exactly what we had when we broke it apart. That's why this technique works. Okay, try this one. Again, a times c. 2 times 3 is 6. So factors of 6 that sum to 7. So it's got to be 6 and 1. Both those have to be negative. And so, again, I don't factor like that. I'm just going to go ahead and break it apart. Okay, and then do your grouping. Grouping here. When I slide that parentheses in, I got to compensate by popping that to a negative. And then pull out your common factor. So common factor here is a 2x, and what am I left with here? X minus 3 minus, again, I understood 1 here, nothing to pull out, x minus 3. So there's my common factor of x minus 3. Pull it out. X minus 3, and what am I left with? 2x minus 1. Again, you can rearrange these terms. You could have put a minus 1x and a 6x. At the end of the day, we should get the same answer in the end. All right, let's try this one. 3x squared plus 5x minus 2. Again, we got to go ahead and do 3 times 2. Give me a negative 6. The factors of negative 6, they're going to give me 5. Well, it's got to be either 6 and 1 or 3 and 2. Now, you may be thinking the negative 3 or 3 plus 2 gives me 5, right? But again, when this is negative, we know that one factor has to be positive and one factor has to be negative. If both of these are positive, that is positive 3 times positive 2 is not a negative 6. So you've got to be careful there. Going to have to be 6 and 1, right? And then where the 1 is negative, 6 is positive. This one's a little bit tricky just because of you're kind of lulled into 3 plus 2 is 5, but Again, because this is negative, one factor has to be positive and one factor has to be negative. So I'm going to rewrite this 3x squared plus 6x minus 1x minus 2. Do my grouping. Again, I slipped that parentheses in between that negative, so I got to change that to a positive. Now what's going to happen? I'm going to pull out my common factor of 3x. And what am I left with? X plus 2 minus, you can put a 1 there if that helps. And I'm left with x plus 2. Again, if I didn't do that, it would show up here and I'd have a plus 2 and a minus 2. Now, it doesn't mean that you made a mistake, but most of these do come out to where you're going to get those. I mean, it really means because the way these are set up, unless it's prime, it's going to work out. So what do we got here? Actually, it will work out because we've already established that the 6 minus 1 is the 5. So this should work out. So if you messed up here, if this off by sign, go back and check to make sure you didn't forget to compensate. Got the common factor of x plus 2. And I pull that x plus 2 out. I'm left with 3x minus 1. We can check that. X times 3x is 3x squared. X times 1 is a minus x. 2 times 3x is a plus 6x. And then minus 2. Again, notice when I check it out, you're going to start to see remnants of my pulling apart that those numbers. I get the same thing. Okay, try this one. 3x squared plus 6x plus 4. Again, I'm going to do a times c. So 3 times 4 is 12. If everything's positive, so factors of 12 that sum to 6. 1 and 12, that's not going to work. 3 and 4, that's not going to work. 2 and 6, that's not going to work. These don't work. We don't have a GCF, so this one is prime.